Welcome students. We are back with another lesson. In this lesson we'll discuss energy level diagram of hydrogen atom. So here we will calculate the various energy levels of hydrogen atom and then we'll draw the energy level diagram for it. So we know the energy expression is given as En equals to twice of pi square mk square Ze to the power 4 upon n square by h square. Here m is the mass of the electron, k is the force constant, Z is the atomic number which is equal to number of protons, E is the charge of an electron, n is the number of the orbit, and h is your Planck's constant. Now, in case of hydrogen atom, you have only one proton inside the hydrogen atom. Therefore, the value of Z in the case of a hydrogen atom will be 1. Therefore, I can write the energy formula as minus twice of pi square mk square. Now, since Z equals to 1, so we can ignore Z. Then we have e to the power 4 upon h square multiplied by n. I will write it separately, 1 upon n square. Now let us discuss for our n equals to 1 orbit. So now let's substitute the value. So 2 is 2, pi 3.14, there is a square here. Next, the mass of an electron is 9.11 times 10 to the power minus 31 kg. The force constant is given as 9 times 10 to the power 9 whole square times the charge of electron is 1.6 times 10 to the power minus 19 to the power 4. Now your Planck's constant is 6.626 times 10 to the power minus 34 square multiplied by 1 upon n square, and in our case we are taking the value of n equals to 1. That is your first orbit. Now when you calculate this value, okay, you can use your calculator to calculate this value. 21.76 times 10 to the power minus 19 joules. Right, now this is the unit of energy. Now let us express this energy in terms of electron volts. To express it in terms of electron volts, we will so you will get minus 13.6 electron volts. Fine. So the energy of the electron which revolves in this first orbit will be how much? It will be minus 13.6 electron volt. Okay, so let us give this energy level. En equals to how much? Minus 13.6. Now let us do the similar calculation for your second orbit. That means this one. for your second orbit, n equals to 2. Now similarly what you can do is, instead of n, substitute n equals to 2. Therefore the energy of the electron in the second orbit can be written as this minus 2 times 3.14 whole square times 9.11 times 10 to the power minus 31 kg times the force constant 9 times 10 to the power 9 whole square times the charge of the electron 1.6 times 10 to the power minus 19 to the power 4 upon 6.626 times 10 to the power minus 34 whole square and n equals to 2. Now if you do this calculation, you will get minus 5.42 times 10 to the power minus 19 upon 1.6 times 10 to the power minus 19. Now why are we dividing this by 1.6 times 10 to the power 19? So that we can convert our joules to electron volts. Right, to convert it into electron volts, we divide it by 1.6 times 10 to the power minus 19. Now when you divide this one, you will get the energy of the second orbit. So the energy of the n equals to 2 orbit is how much? It is 3.4 minus 3.4 electron volts. Fine. So we have calculated the energy for the first orbit. We have calculated the energy of the electron in the second orbit. Fine. Now, instead of repeating this whole calculation, okay, instead of repeating this whole calculation, what I can do here is that I can calculate this value in terms of electron volts first. Okay, why? Because this term is constant. For n equals to 1, this part is same as compared to n equals to 2. Here everything is same. The only difference is coming because of this n. Can you see? Here for the second orbit n equals to 2. For the first orbit n equals to 1. So everything is same. The only difference, everything is same here. The only difference is in the value of the number of orbit. This value. Fine. So what we can do is we can first calculate this part. Fine. So let's calculate this part first. Okay. So let's write it down here. So if I substitute these values, okay, 2 is 2, pi is 3.14, m is 9.11 times 10 to the power minus 31, k is 9 times 10 to the power 9, e is 1.6 times 10 to the power minus 19, h is 6.626 times 10 to the power minus 34, and the respective powers. Okay, now if you do this calculation, you will get 21.76 times 10 to the power minus 19 joules. Right? So again, to convert it into electron volts, what we do, we divide it by 1.6 times 10 to the power minus 19. Now if you do this calculation, you will get minus 13.6 electron volts. Okay, so can you see the value of this constant part, minus 2 pi square mk square e to the power 4 upon h square. The value of this constant part is how much? Minus 13.6 electron volt. Okay, I'm not considering this 1 upon n square for now. So this part is minus 13.6 electron volt, which is also similar to your energy level of the first orbit. This is also how much? Minus 13.6 electron volt. So from here, can you see this part is how much? It is equals to 13.6 electron volt, which in turn equals to E1. Fine. So instead of this constant part, minus 2 pi square mk square e to the power 4 upon h square, instead of writing this part every time like this one, or instead of calculating this part every time, what I can do is I can simply write this E1. And by E1, I know what does the E1 value is? Minus 13.6. So let's substitute minus 13.6. Fine. So this part I can write as E1. divided by your n square. Right. So my energy level expression can be written as the energy of the first orbit upon the number of the orbit square. Fine. So now let's do the calculation again for your second orbit. So using this method, let's calculate the energy of the second orbit, E2. Okay, let's see whether we get the same value or not. So using your method 2, I can write your energy level E2 as energy level of E1 divided by n square. And in this case, what is the value of n? It is 2. So I'll substitute 2 here. So E1 is minus 13.6 divided by 2 square is 4. And the unit electron volt. Fine. So if I do this calculation, okay, this will be 4 3s are 12, remaining 4, so 4 4s are 16. So you should get minus 3.4 electron volts. Fine. So the energy of the second orbit is minus 3.4 electron volts, which is similar as this one. So instead of doing all this tedious calculation, we can simply use this method. Fine. Now in similar manner, you can calculate for the third orbit, the energy for the third orbit. Similarly, the energy for the fourth orbit. Similarly, calculate the energy for the fifth orbit and the energy for the sixth orbit. So you can calculate this energy levels. Okay, you can take this one as your homework. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.